This is example 5 in our lesson on graphing square root functions. And what we notice in example 5 is that we have the parent square root function that has been shifted to the right 4 units. And I'd like to graph this from the perspective of the parent function. So let's go ahead and graph y is equal to the square root of x. And we get these ordered pairs. And in this case, I'm shifting to the right 4 units. So each one of these points is going to go to the right 4 units. 0, 0 is now going to be at 0, 4. This is going to shift to the right 4 units. You could actually just count this over. 1, 2, 3, 4. So 1, 1 is now going to be at 5, 1. And let's count 1, 2, 3, 4, and we'll notice that 4, 2 ends up at 8, 2. And if I connect my ordered pairs, I have a graph that looks like that. And we can see that the square root function did shift to the right. So our transformation would be a horizontal shift and it went right 4 units. Our domain has changed, though. The domain for the square root function is normally x is greater than or equal to 0. But in this case, what we notice is we can't substitute these values between 0 and 4. If I do, if I put a 2 into the function, 2 minus 4 is -2, and I can't take the square root of -2. So we have to exclude these values from the domain, and we have to say that x is greater than or equal to 4. So when you shift a square root function horizontally, you're going to affect the domain. You're not going to affect the range, however. If we take a look, y is greater than or equal to 0. I can have a y value that is 0. And I also have all these positive y values. My x-intercept is now at 4, 0. But notice I don't have a y-intercept anymore because I've shifted my graph off the y-axis. So there is no y-intercept. So let's go ahead and do example number 6, just the same way. In this case, we're shifting left 5. So let's graph our parent square root function. And I'm going to graph that in lightly. And then I'm going to shift each one of my points to the left 5 units. So 0, 0 happens at -5, 0. And again, you can just count over 5 units. 1, 2, 3, 4, 5. And 4, 2 is now going to happen at -1, 2. And if I take 9 and subtract 5, I'm at 4. So there are my shifted points, and I can make my graph based on that. My transformation in this case was to go left 5 units. Again, a horizontal shift. Left 2 units. Oh, excuse me, 5 units. And again, I know when I shift horizontally, I affect my domain. So x is now greater than or equal to -5. And oftentimes I hear students say, but Ms. Van Vickel, you can't take the square root of a negative number. Look what happens when I plug -5 back into my equation. -5 plus 5 ends up being 0, and I can take the square root of 0. So now I have x values that are negative, but they don't make what's underneath the radical symbol negative. My range is the same. I haven't shifted up or down, so I have a y is greater than or equal to 0. My x-intercept is now at -5, 0. In order to find my y-intercept, I would have to plug in 0 for x. So y is equal to the square root of 0 plus 5. And y would be equal to the square root of 5. So I would simply say when x is 0, y is the square root of 5. And really, I would leave it that way unless I needed to graph it. And if I needed to graph it, then I'd have to put it into my calculator and make an approximation for what the square root of 5 is. So that's it for example 5 and 6. The next video will explore example 7 and make generalization.